Assalamualaikum. My name is Nur Anazuha Hizzaman, UK34949. The importance of variation in stochastic calculus. What is variation? Variation is a field of mathematical analysis that deals with maximizing or minimizing functions. These functions are often expressed as definite integrals involving functions and their derivatives. The interest is in functions that make function attain a maximum or minimum value, or it can be stationary function, and this rate of change is the function is zero. Variation of a function. If g is a function of real variable, its variation over the interval from a to b is defined as supremum summation of I equal to 1 until n gpi minus gpi minus 1, where the supremum is taken over the partitions from t0 until tn, which is in between the point of A and B. By the triangle inequality, the sums in of the first equation above is increased as new points are added to the partitions. Therefore, the variation of g is limit delta n approaching to 0, summation I equal to 1 until n gpi minus gpi minus 1. Quadratic variation. If g is a function of real variable, we find its quadratic variation over the interval from 0 to t as the limit at this. Gp is equal to limit delta n approaching to 0, summation of I equal to 1 until n gpi minus gpi minus 1, with the partition with 0 equal to t0 until tn, but still in between the point of 0 and t, where the delta n is equal to maximum t is in between 1 and n. Similarly to the concept of variation, there is a concept of p-variation of a function, where the p-variation is supremum summation I equal to 1 until n p gpi minus gpi minus 1, where the supremum is taken over all the partitions. Like before, quadratic variation has a p-variation, and this quadratic variation of Brownian motion also has a quadratic variation. The quadratic variation of a Brownian motion on the interval is defined to be, we can let Brownian motion also as a b and also as a y. Limit delta n approaching to 0, summation of I equal to 0, approaching until n minus 1, ypi plus 1 minus ypi squared, where for each n is a partition of between point 0 and t, and the limit is in probability taken over partition with delta n equal to maximum pi plus 1 minus pi, which is approaching to 0 as n approaching to infinity, and is given by that equation. It is remarkable that although the sums in equation are random, their limit is non-random. Brownian motion has a properties that is quadratic variation on interval 0 to t equal to t for any t. Standard calculus. A continuous differentiable function has zero quadratic variation if any continuous deterministic process has a well-defined quadratic variation along all partitions is zero. Any continuous stochastic process or function that has non-zero quadratic variation must have infinite total variation. Stochastic calculus. Ito calculus for Brownian motion and martingale. Stochastic analysis of process related with fractional Brownian motion and numerical schemes for stochastic differential equation. So I can conclude that quadratic variation plays a major role in stochastic calculus, but hardly ever met in standard calculus due to the fact that most functions have zero quadratic variation. That's all from me. Thank you.